Hey everybody, here are the notes for homework number 17, part 2, which is essentially just setting up formulas for things. I know that's not very specific, but it's kind of how it is. I'm setting up formulas for volume, surface area, etc. in one variable. So often, especially in the first quarter of calculus, 17A, 21A, 19A, you'll want to be able to set up the equation or formula for the volume of a box or the surface area of something in terms of just one variable, but you often have to start off with two. So here's an example. A box with no top has a square base and holds a volume of 32 cubic feet. Write a formula for the surface area in one variable. So typically problems like this, there are two things going on. There's a constraint and there's the thing that you want to write an equation for. So if we start off with the thing we want to write an equation for, we want to write an equation for the surface area. So that's going to be the area of all the sides added up together. So we have the surface area is going to equal the area of the bottom, which is x times x, the area of this front face here, which is going to be x times h, the area of the side face here, which is also x times h, the area of this back face here, which is also x times h, and the area of this left face here, which is also x times h. If it was a box with a top, we'd have another x squared to add on because there'd be 6 sides, not just 1, 2, 3, 4, 5 sides. We can definitely simplify this and write it as surface area equals x squared plus 1, 2, 3, 4, 4 times x times h. The problem with this formula is that it has two variables, x and h. And I really want to be able to write it in terms of one variable. So what we need is some sort of constraint or defining piece of information. In this case, it's that the volume of the box is 32 cubic feet. So we're going to say that the volume is equal to, well, we know an equation for volume. The equation for the volume of a box is base times width times height, or length times, whatever you want to call them. It's one dimension times another dimension times a third dimension. So our volume is x times h, or x squared times h. But we are told, or we are constrained by the fact that the volume has to be equal to 32 cubic feet. Then what we can do with our constraint, and this is the constraint, is the equation that has to be equal to some number that's given to us typically, is now we're going to solve for h in terms of x squared. So we're going to take this and we're going to divide both sides by x squared and get that h is equal to 32 divided by x squared. And then we're going to take that expression for h and plug it back in for the h right there. So our new surface area equation is going to be x squared plus 4x times 32 divided by x squared. Usually it's in your interest to simplify this. You can cancel an x here and an x here, so we could rewrite this as surface area equals x squared plus, we'll cancel an x there and an x there, so we'll just get one x in the denominator, and 4 times 32 is 128. We could write it like this, or if it's preferable, you can write it as surface area equals x squared plus 128 times x to the negative first. Either way would be acceptable. You might prefer one versus the other for various reasons. So this is how you'd write the equation for the surface area of a box in one variable where the box has to hold 32 cubic feet. And the base is square. If the base wasn't square, we couldn't do this because then you'd have a different variable for the side length here and the side length here. So usually you're starting off with two variables and working your way down to one. There's another example. The hypotenuse of the right triangle is 5 units, inches, meters, whatever. Set up a formula for the perimeter of the triangle using one variable. So the thing we want to set up the formula for is the perimeter. Perimeter, I think that's how you spell it. Doesn't really matter. So that's going to be, I would use the letter P. So P is equal to x plus y plus 5. But as you might have noticed, there's two variables there, x and y. I will point out that P is not a variable. P is like the function. If you really wanted to, although I don't really want you to, you write P is a function of x and y. It's equal to x plus y plus 5. But I would just stick with this for now. So then we need to get rid of one of those variables. So we're going to take this right triangle and we're going to find a way to a constraint. In this situation, our constraint is that we know the hypotenuse is 5, but we're going to use that to write an equation. Typically, here we're going to use the Pythagorean theorem. So we're going to say that x squared, and let's write our constraint here. Our constraint is that x squared plus y squared has to equal 5 squared, or that x squared plus y squared equals 25. And this is a situation we could isolate either variable. Let's do something maybe slightly atypical and isolate x instead of y. So we're going to say that x squared is equal to 25 minus y squared, and then we're going to take the square root of both sides. Normally, we would say that x was equal to plus or minus the square root of 25 minus y squared. But in this case here, right, not 5 minus y, right? We can't just square root each part. It's got to be the square root of 25 minus y squared. But since we know that x is representing the length and it's positive, we should just say that x is the positive square root of 25 minus y. So then we can rewrite our perimeter equation as perimeter is equal to, we're going to replace x with all this. It's going to be the square root of 25 minus y squared. We didn't really need parentheses there. I kind of want to write to show you that this is like our x plus y plus 5. Or writing it out without the parentheses because they look kind of silly. The perimeter is equal to the square root of 25 minus y squared plus y plus 5. And that is the equation of our perimeter in one variable, just using y. You could have gone the other way, right? You could have solved for y here and said y was the square root of 25 minus x squared, and then your equation would have been the perimeter is x plus the square root of 25 minus x squared plus 5. Essentially the same, just using x's instead of x. So that's kind of the general idea. Is there something you want to write an equation for in terms of one variable, but starting out with usually two, and some other constraining piece of information that's going to give you an equation that allows you to solve for one variable in terms of the other, and you can plug that back in the place of one of the two variables you want to get rid of. Well, replace with the other one. One more example. A cylinder has a surface area of 80 pi centimeters squared. Find a formula in one variable for the volume of the cylinder. So let's talk about the volume of a cylinder. Typically, we think of it as the base area, which is the area of a circle, times the height. So the volume of a cylinder is given by the base area, which is pi r squared, which is base area, times the height. So we would write this as just volume equals pi r squared, your typical cylinder volume. Okay, so that's our thing we want to write in terms of one variable, but we have it in terms of two. So we're going to find the constraint. And this time the constraint is that the surface area. Oh, yeah, no, the surface area is yeah, that's right. Yep. So we need to find the equation for the surface area. It's a little bit tricky for a cylinder. I will point out the cylinder has a top and a bottom. The area of the bottom and the top are both circles, so the area is going to be a pi r squared plus pi r squared. So the surface area is going to equal pi r squared plus pi r squared is 2 pi r squared. And then the around part of the cylinder is always a little bit tricky. Here's the way I kind of think about it. Let me draw it again here. So I think about it as kind of like a roll of paper towels. And if I took off one paper towel that went exactly all the way around, and I unrolled it, I'd have a rectangle. And that rectangle would still have a height of h, but the length would be what you get when you go all the way around the circle, which is the circumference of a circle. So this length here would actually be the circumference of the circle of radius r, which is 2 pi r. So the area here is 2 pi r times h, or the length times the width of this rectangle. So the surface area of the cylinder is the area of the top circle, area of the bottom circle, plus the area of the around part. And then we know that that's equal to 80 times pi. And now we want to isolate one of these two variables. I'm going to pick h here because there's an r here and an r there. That's going to be harder. I'm going to pick the h to isolate because it's only one h. I would also point out that since each part of this has a pi, we can actually divide both sides by pi. And so I've kind of sucked up this room right here, so let me scooch down a little bit. So if I take my equation, 2 pi r squared plus 2 pi RH equal to 80 pi. The first thing I'm going to do is actually divide everything by pi. You just get 2r squared plus 2RH equal to 80. I guess I could divide everything by 2 pi. That might have been smarter. Let's divide everything by 2 and get r squared plus h. Oops, so I lost an r right there, plus RH equal to 40. Okay, so now RH equals 40 minus r squared, and h is equal to 40 minus r squared divided by r. Or 40 divided by r minus r squared divided by r is just r. Either way would be fine. We're going to plug either one of those back into the volume equation up here. So then volume, which was pi r squared times h, is now going to be pi times r squared times 40 minus r squared over 1. And then I do kind of like writing it this way because I don't always need to do this, but I could cancel an r here and there and get volume equal to pi times r times 40 minus r squared. Cool. So either one of these would be totally acceptable. That's the general idea. You have the thing you're trying to write as a function of one, or an equation in one variable. You have your constraint. You take your constraint, you solve for the easier thing to solve for. Sometimes it doesn't matter either way. Like the previous one, x or y would have been fine. Here, it's definitely better to solve for h in terms of r. So we get h in terms of r, and then you just plug that back in for the h right there. So right, the h right here became all that right there. There we go. That's it. All right.